So, second semester of AP Calculus. The entire second semester is all about finding the area under a curve. That's like 99% of what we're doing is connected to finding the area under a curve. So first we need to talk about estimating the area under a curve. And that process is called Riemann sums. A Riemann sum is a sum of shapes, whether we're using rectangles or trapezoids, that we use to approximate the area under a curve. And there are specifically 4 methods that I need you to be familiar with. The first one is called LRAM, which stands for Left Rectangle Approximation Method. So let's say if I wanted to approximate the area under this curve between A and B, left rectangle approximation method means I need to draw rectangles so that the left side of the rectangle is on the curve. All right, notice that the left side is on the curve. I'm going to draw the middle interval. I'm drawing another rectangle so that the left edge is on the curve. Again, the left edge is on the curve. So this is left rectangle approximation. Pay attention to whether we're getting an overestimate or an underestimate. If I use the area of these 3 rectangles to approximate the area under the curve, this is going to be an overestimate because I'm including this extra area that is actually above the curve. So we'll come back to that in more detail, but that's the first method. The second method, you can almost guess what I'm going to do for the right rectangle approximation method, RRAM. That just means when I draw my rectangles, the right edge of the rectangle will be on the curve. So see how the right-hand side is on the curve. The right-hand side is on the curve. The right-hand side is on the curve. You can probably see that this is going to be an underestimate because these rectangles are leaving out some of the area that's under the curve. Okay, the third method is called MRAM, which stands for Midpoint Rectangle Approximation Method. So in this case, we draw our rectangles so that the midpoint of each rectangle is on the curve. I'm trying to estimate. So this would be the midpoint of the rectangle, which would be on the curve. Okay, draw your rectangle so that the midpoint of the rectangle is on the curve. All right, and this is what is meant by the MRAM method. In terms of whether this is an overestimate or an underestimate, this is a little bit harder to see because you have, in each rectangle, you have a little bit that's left out and a little bit extra. All right, there's a little bit of both. So I'm going to come back to that question later. The fourth and final method is called TSAM, which stands for Trapezoidal Sum Approximation Method. So real quick, when we talk about trapezoids, when you learned about trapezoids back in geometry, you had pictures like this. This is your classic trapezoid. And we would say this is base 1 and this is base 2. And we would talk about the fact that the area of a trapezoid is 1/2 base 1 plus base 2 times the height. And the height of the trapezoid was the distance between the bases. So this was the height. Now, I'm betting that you will agree that if I were to flatten out one of these sides, so let's say if I took this and I made it a vertical line, this is still a trapezoid. Okay? Now, imagine that we took this trapezoid and we rotated it so that it's on its side. Maybe I'll just do that real quick. I'm going to take this trapezoid and rotate it. Okay, so now we have this sort of sideways parabola where the bases are now vertical. So this would be like base 1 and base 2. And the height is now more like a width. All right, so these are the kind of trapezoids that we will use to estimate the area under the curve for the TSAM method. So it kind of goes like this. In the first interval, I'm going to make my 2 vertical lines on either side of the interval. But then I will complete the trapezoid by connecting the tops of those vertical lines. So maybe you can see that this is going to be a little bit of an overestimate. Let's go ahead and write that down. Overestimate. Because you can see the tiny amount of extra space that's being included. But let's keep going. For the middle interval, here's another trapezoid. And then for the third interval, here's a third trapezoid. You can probably tell that the trapezoid is giving us a better approximation because of the way it more closely hugs the curve. So that's something to be aware of. So let's talk more about whether or not we're getting an overestimate or an underestimate. So you'll notice that I'm pairing these methods together. So LRAM and RRAM sort of go together, and then MRAM and TSAM go together. So here's the thing that I need you to memorize. For LRAM and RRAM, left rectangle, right rectangle, what matters is the function increasing or decreasing? That's what matters. Okay, so notice that in this case, the function is increasing. So you don't have to memorize whether it's an overestimate or an underestimate, because watch how easy it is to make a quick sketch. If I draw a quick left rectangle like this, bam, left rectangle, the left edge is touching the curve. You can easily see that this is going to be an underestimate because we're leaving out this space that is under the curve. It's being left out. So for the notes here, we can say that, look, LRAM gives you an underestimate when the curve is increasing. So let's drop down here. We're talking about LRAM. It gives you an underestimate when the function is increasing. Okay, let's draw a function that is decreasing and see the difference. So here's a function that is decreasing. Let's do another LRAM and see what it looks like. So here's another LRAM, left rectangle, left edge touching. And this time you can see that it is an overestimate because we're including all of this extra area. Okay, so LRAM is an overestimate when the function is decreasing. All right, you don't have to memorize whether it's going to be an overestimate or an underestimate. Just draw the picture. All you have to memorize is that what matters is whether it's increasing or decreasing. You can probably guess that RRAM is going to be the opposite. So let's draw a quick right rectangle. All right, the right edge touches the curve. So in this case, we have an overestimate. There's extra area here. So RRAM is giving us an overestimate for when the curve is increasing. Okay, so RRAM gave us an overestimate when the curve was increasing. So if we draw a curve that is decreasing, and if we do another RRAM, okay, the right side touches. This time we're getting an underestimate because we're leaving out all of this area under the curve. So it's an underestimate when the function is decreasing. Okay. Now I've grouped MRAM and TSAM together because these, instead of depending on whether the curve is increasing or decreasing, it's all about concavity. All right, what matters is the function concave up or is the function concave down? So that's what you need to memorize, is that MRAM and TSAM, it depends on concavity. So obviously, this example 1, these are concave up. So let's do the TSAM. I'm going to come back to the MRAM because the picture doesn't actually help you for MRAM. So let's do TSAM. The T stands for trapezoid. So let's draw ourselves a trapezoid. Okay, trapezoid, come in. Okay, and connect the tops. So you can see that in this case, we're getting an overestimate because the trapezoid is including all of this extra area that's not under the curve. So that tells us that TSAM gives us an overestimate when the function is concave up. Okay, let's write that down. So TSAM gives us an overestimate when f of x is concave up. All right, so let's draw a picture that's concave down. See what happens. Okay, there's a picture that's concave down. Let's do another trapezoid. Okay, trapezoid, blam, blam. Okay. And now you can see that this is going to give us an underestimate because this trapezoid is missing some area under the curve. All right, so TSAM gives us an underestimate when the function is concave down. Now, I'm not going to bother drawing the picture for MRAM because it doesn't really help you. Instead, I want to tell you that TSAM and MRAM are opposites. So just write this down. They are opposites. Okay, so when it comes to the midpoint rectangle approximation method, if TSAM gives an overestimate when the curve is concave up, then MRAM will give an overestimate when the function is concave down. If TSAM gives an underestimate when the function is concave down, then MRAM will give an underestimate when the function is concave up. Okay, so we will assess MRAM indirectly. All right, we will look at a trapezoid and then we'll do the opposite. So we'll practice that later. So let's move on to example 1. Approximate the area under the graph of y equals 2x to the third power on the interval from 2 to 10 using MRAM, midpoint rectangle approximation method, and 4 subintervals of equal width. So they helpfully gave us a picture for this one. Usually we have to do it ourselves. So we're talking about the area under the curve from 2 to 10. And the 4 subintervals are right here. So that's the first subinterval, the second one, the third, and the fourth. So from 2 to 4, 4 to 6, 6 to 8, 8 to 10. So back on the chart, let's record that. So the intervals, the subintervals are 2 to 4, 4 to 6, 6 to 8, and 8 to 10. Okay, they're saying what x values are we going to use? So I think I'm just going to focus on one interval as an example. I'm going to make an example out of this interval. So focus on the interval from 6 to 8. This is midpoint rectangle approximation method. So I'm drawing this rectangle so that the midpoint is on the curve. Right about there. So this is the midpoint right here. So notice that the midpoint is at an x value of 7. So that's the x value to use is going to be 7. Similarly, between 2 and 4, the midpoint will be 3. Between 4 and 6, that's 5. Between 8 and 10, that's 9. Okay, now we need to know the height. Ultimately, we need to calculate the area of 4 rectangles. But part of that, we're going to need the height. So what is the height of this rectangle? Well, because the midpoint is on the function, the height of the rectangle is going to be the value of the function at the midpoint, which in this case is 7. So we have some calculations to do. Remember that the function itself is 2x to the third power. So the value of the function at 7 is going to be 2 times 7 to the third power. So that will be the height of the rectangle. Normally I would simplify this, but these numbers are too big, so I'm just going to leave it the way it is. So similarly, the height of the first rectangle would be 2 times 3 to the third power. And the height of the second rectangle would be 2 times 5 to the third power. And the height of the fourth rectangle would be 2 times 9 to the third power. To calculate the area of this rectangle, we need to do base times height. So we have the height, now we need the base, or the width. Well, the width of the interval is just going to be, the distance between the numbers. It's the, it's 8 minus 2. So the width of the interval is 2. And these are 4 intervals of equal width, so they're all going to be 2. Okay, so the width of each rectangle is 2. 2, 2, 2, 2. So finally, for the area is just base times height. And we're going to add up all 4 areas. So the first area, base times height, is, hold on, I want to do it's time for a different color. So base times height, it'll be 2 times 2 times 3 to the third power. All right, that's the base and then the height. And then I'm just going to add that 4 times. So for the second rectangle, it's 2 times 2 times 5 to the third power. Third rectangle, 2 times 2 times 7 to the third power. Fourth rectangle, 2 times 2 times 9 to the third power. And just leave your answer like that. Okay, example 2. Approximate the area under the graph of y equals 4 times the square root of x on the interval from 0 to 9 using TSAM, Trapezoidal Sum Approximation Method, and the subintervals indicated below. So we're going to be doing trapezoids. Part of this is you have to know what your parent functions look like. So for example, when I see the parent function y equals the square root of x, I automatically know that that looks like this. Okay, that's what the curve looks like. So when you put a 4 in front of it, that's a vertical stretch, but that does not change the shape of the curve. So you have to know your parent functions. Okay, so I'm going to put this curve sort of over the top of this trapezoid so I can use it as a model. So let's say this is my x-axis right here. This is my y-axis. Let's see, can I do this? So I'm just going to draw my curve. So that's hitting this. Man, this is hard to do. Hold on. Okay, that's pretty good. So this is the function y equals 4 times the square root of x. So I'm going to use 3 trapezoids to estimate the area under this curve between 0 and 9. But so for right now, let's do the middle interval. So between 1 and 4, let's think about what's going on. In terms of which x value to use, I normally don't even put this row on a TSAM chart because we always just use both. We're going to use both of the values. Because remember that this is a sideways trapezoid. So over here on the left, this is base 1. And this red piece over here, this is base 2. Okay? So, and in fact, instead of talking about the height as though it were a rectangle, cross that out and put base 1, comma, base 2. Okay? That's what we're going to put on this row. So, I need to figure out what is the height of base 1. Base 1 equals what? Well, base 1 is touching the function. Okay? So, it's going to be the value of the function at 1. In other words, if I take the function and plug in 1, that's 4 times the square root of 1. So that's 4. So for this interval, base 1 is 4. What about base 2? What's base 2 going to be? Well, base 2 is going to be the value of the function at 4. Okay? Because base 2 is touching the curve. So it's going to be 4 radical 4. That's 4 times 2. That's 8. So base 2 is 8. Okay? So just applying that to the other intervals real quick. We literally already calculated the height at 4. So we already know that that is 8. So it's going to be 8 comma something. We calculated that the height of the function at 1 is 4. So in the first interval, it's going to be something, comma 4. Okay, so what is the height of the function at 0? Well, that's just going to be 4 times the square root of 0. So that's going to be 0. What is the height of the function at 9? That's going to be 4 times the square root of 9. That's 4 times 3. That is 12. Okay, so we have base 1, base 2 for all 3 trapezoids. Now, ultimately, we need to find the area of each trapezoid. And for that, we're going to need the height of the trapezoid, which we can think of as the width of this trapezoid. The width of the interval is the same as the height of the trapezoid. So between 1 and 4, the width is 3. All right, it's like 4 minus 1. So for this interval, the width is 3. Okay, between 4 and 9, the interval from 4 to 9 has a width of 5. Between 0 and 1, that interval has a width of 1. So that's the width of each trapezoid. Now we have enough information to write 3 trapezoid areas. Again, please remember that the formula for the area of a trapezoid is 1/2 base 1 plus base 2 times the height, or in this case, the width. So I'm just going to do that 3 times. So here I go, 1/2 base 1 plus base 2, that's 4, and then times the width, which is 1. 1/2 base 1 plus base 2, that's 12, and then times the width, plus 1/2 base 1 plus base 2, that's 20, and then times the width. So this is an expression for an estimate. This is our estimate for the area under the curve between 0 and 9. And you would just leave your answer like that. Oh, is this approximation more or less than the true area? Well, you can probably see if you squint really carefully. This is going to be an underestimate because we are leaving out a little bit of area. Or you could look back at our notes when we talked about for TSAM. We're always going to get this underestimate when the curve is concave down. Okay, and this curve is concave down. So we're going to say, is the approximation more or less than the true area? It is less. And then here comes your justification, because, and we just have to say because the function is concave down. So because y equals 4 radical x is concave down. All right, that's what you put for your justification. All right, it's always going to be either the concavity for MRAM and TSAM. All right, these are the 2 justifications. Or if it's a LRAM or RRAM, your justification will be either increasing or decreasing. Okay. Example 3. F is continuous. Approximate the area under its graph on the interval from 3 to 12 using RRAM and the 3 subintervals indicated. Okay. So I'm just going to draw a quick model off to the side. We don't really know what this function looks like. Hold on. I wanted this to be gray for some reason. Okay, why are my colors not working today? Okay, anyway, we don't really know what this curve is going to look like, so I'm just going to do something random. Okay, random curve. Now, we're doing RRAM. So I'm going to just do a right rectangle real quick. I'm going to throw, oh, that's not a rectangle. Try that again. Remember, for right rectangle, it is the right-hand side that should be touching the curve. In fact, I want to make it a little bit more obvious that it is the right-hand side that we're looking at. Kabam. So let's say that this is representing the interval. It says 3 subintervals indicated. So we're talking about, these are the intervals. So 3 to 5, 5 to 9, 9 to 12. Okay. These are the subintervals. So let's say that this rectangle represents the interval from 9 to 12. So if I were you, I would make a little chart. So I'm going to make a little chart right now. Okay, we're going to need a row for the intervals. We're going to need a row for the base, and we're going to need a row for the height. Okay, so intervals. Do I need to? Okay, I think that'll do it. So we have intervals. The intervals are 3 to 5, 5 to 9, and 9 to 12. The area of a rectangle is base times height. Okay, so I'm going to need to know what the base is. So I'm just going to put base, and I'm going to need to know what the height is in order to find the area. So the base of each rectangle is just the width of the interval. So from 3 to 5, that's 2. From 5 to 9, that's 4. And from 9 to 12, that's 3. Now, what about the height of each rectangle? Remember that this is RRAM. This is right rectangle. So the height of the rectangle will be the value of the function at the right side of the interval. So we should be focusing on the 12 in this case. And in the other intervals, it will be the 9 and the 5. It's right rectangle, so look at the right side of the interval. So what is the value of the function at 12? Well, the table tells us that is 13. Similarly, the value of the function at 9 is 8. And the value of the function at 5, 7. So now we can put an expression for the area. All right, it's 3 rectangles, base times height. So we just do 2 times 7 plus 4 times 8 plus 3 times 13. And you just leave your answer just like that.